Right. So our topic for today is OOP. OOP. And do any of you know what OOP stands for? Yeah, something like that. Okay, it's misspelled. It's the E with the dot thingies, I think. Okay, well, let's go. Orientated programming. All right. So the whole idea behind this, you can, because with this section as well, they love asking theory questions out of this as well. So over and above having to apply this in a practical sense, you actually also have to understand these concepts because you're going to get it in your theory paper as well. So object-oriented program, and we do have benefits of this. What do you think is benefits of having this OOP, or object-oriented programming? Did you guys go through that? Or if you think about it, those of you that started using this, what do you think is benefits of this? Yes, so we can reuse code. Or what does that tell us? Say again, if it's modular, then what? Okay. So yes, OOP is basically modular programming. That's what it is. So, and one benefit is we can now reuse code. So we can have one section of code and just have lots of pointers to that. So what I mean with that is, let's say you had 5 buttons that wanted to sort an array. Each of them you could just actually, you can write the sorting of an array code once, and just whenever you want to do that, that button can just refer to that section of code. So that goes with reusability. Um, what else? Yes, like a display procedure, exactly like a display procedure. So that is one of the advantages. But what else do you think would be another advantage of having it like that? Okay, so the next one would be easy fault finding. Because now, if there's an error in the display, you can actually know where to go. And then another one is quick fixing of errors. Because now, if the display is wrong, let's say we did this example where I did, we had the sort, we want to do it 5 times. Now some of you can say, oh, but so couldn't we just take that code, copy it, and paste it 5 times? Because don't actually use any of your time. The problem is having that section of code copied and pasted. Remember, the computer doesn't know it's doing the same thing. So for him, he will need to do that every time over. While if it was so, no, sorry, let me just finish that. So if we refer to that place, and let's say we realize that that part of code, it didn't sort it correctly. Now you need to go to all 5 places and go fix it. Let's say the greater than sign should have been smaller than. You didn't want it ascending but descending. But now you need to go to 5 pieces of code to go change it. While if it was just in one place, you could just fix that one place and it would be fixed all over automatically. You must remember, code, like in programs like Windows and all the programs we're using nowadays, there's really a lot of lines of code in it. We're talking about millions. So if you needed to go fix something, a few years back, the our VAT percentage was 14%. So the people that hard coded that 14% everywhere, if that now changed, like it changed to 15, they needed to go every single place they used it and go change. And you can't just use a find replace, because what if that 14%, there was a 14%, but it showed to something else. Maybe it showed to the amount of petrol you use or whatever. So you can't just change all 15s to all 14s to 15s. And it's sort of the same with the code. You can't say change all the greater than signs to smaller than signs. Then it's going to maybe change other places as well that it shouldn't have. So you can actually fix errors much quicker, and you can find the errors quicker. And we can reuse code. Reusing code actually makes our program faster. It will execute faster, it will program faster, and it uses less storage. Let me just see, and then there was a question here. Accessing the same code from a different programs. So no, not different programs, it's within the same program. But remember, like we're doing now. So what this is, remember, we're going to create a unit now, our main program, which will have a GUI and everything. And then we're going to create a separate unit that our main program will use. So examples of that is, like when we do a random number, we can just use that random function and we get a random number. But that random function actually comes from the math class. So somebody created code that will generate a random number. And every time we want a random number, we can just call that method. And that's sort of what we want to do now as well. We want to create these independent, how to say, smaller programs. And every time you want to use it, you could just refer to that and use it to make life easier, because nobody, it's like reinventing the wheel. If you needed to do a random number and we didn't have that random function, you needed to think of your own type of code to generate it. But now having that, it makes our life easier. So it can be, to answer Winner's question, so you can refer to it from different programs or units, or it can be in the same one. It doesn't need to be. Like last year, we had our display as a separate method, and we could call it the whole time. So that's also a benefit. So we shouldn't confuse it. Not all of that is part of object-oriented programming. But object-oriented programming is definitely also having the separate methods. We'll get into what an object is just now. But yeah, so these things are benefits for us for using OOP. They really like asking that as well, just saying what would the benefits be of modular programming or OOP. Yeah, everybody good so far? All right. So let's look at some words. Our first thing is an object. So to explain an object, I want to say object, if you keep in mind, I think it's a noun. I think it's the right word. My English is not that good, but I think noun is the one. Is noun something like a table or a chair or a car or a person? Am I correct? All right. Yes. So object, if you've got that like a noun in your head, then you understand sort of what an object is. An object is that thing. So an object in our case is something that will have attributes and have actions. So it's something that can have attributes and have actions. And that's sort of what an object is. So what we want to do is we want to create objects that actually hold multiple values. Up until before OOP, you guys had variables and arrays to put stuff in. So variables could only have one value. Then we had arrays where we can put multiple values in, but only of the same data type. But now, like remember end of last year, or the last array ones we did, when we did linked arrays, we had something like for action figures. Then you had a name and you had a price and you had maybe a weapon or whatever. So then we had to have these linked arrays to keep track of all the values for each object. And remember at that stage, they weren't actually linked. We just sort of linked it with code, so that the first element in each array referred to the first object and the second element referred to the second object. And when we sorted, can you remember we needed to When we swap the one array, we needed to swap the other one and the other one. We needed to swap all three arrays. Can all of you remember that? All right, so what an object does for us now, we can actually group all these things together into one thing. So we're going to create an object that can actually store all these values in one. So yes, and that's our attributes. That's sort of like the values of the object. If we think of our action figure, attributes would be the price and the name and the weapon or whatever. So all of those things would be attributes of the object. All right, then another word that we need to know or look between is functions and procedures. Or function and procedure. Skip to the singular. You guys have been working with OOP now. Do any of you know what is the difference between a function or a procedure? All right, well done. And the procedure? Yeah, yeah. All right, so value just as an action. So the way to see this is, I always like use the example, if you're like in a class scenario and somebody, let's say the teacher asks any of you to go and close the door. You just go and close the door. So you're not going to ask the teacher anything. You're just going to go do the action. And that's basically a procedure. So procedure just gets done, but nothing gets returned. You don't need to say anything to the teacher back afterwards or whatever. So that's your procedure. By you just do it and there's no response needed. While if the teacher asked you, go find out how many chairs are there in the class next door, that will be a function because you need to go there, you need to go count, and when you come back, you'll tell the teacher 25 or 30 or 40 or 50. So that's a function. So the function is when we've got a method that needs to do something, but when it's done, it's going to give us an answer. If it returns a value, then it's a function. However, if it just needs to do something and then it's over and done with, it's a procedure. So generally with a procedure, that's our display type of functions. So you work something out, and if the method already displays the answer, then it's a procedure. But if the method is going to send the value back to be displayed later, then it's a function. So we're getting a value back. So the main thing is we look at what the method must do, and if it's going to return something, and generally your questions will be very straightforward. It will say, write the method that does this, and it will return an integer. Then you know it's a function. So generally you can, like 99% of the time, the word return will be in the question. And then you know, okay, I must use a function. And generally if it just asks you, just do this or just display this, then you know it will be a procedure. Like the display we did last year, you will remember those ones were always procedures. Because what it did, it just displayed the array. And then it was done. There was nothing that, it didn't need to send a value to another method within our program. All right. And then our next word we need to know is a parameter. So parameter refers to the round brackets. I'm going to show you now where we're going to use all these things like practically. But I'd like to just get these words so that we've got an understanding of what we're doing. So those of you that's been working with OOP, what's the function of a parameter? All right, no one knows. So the parameter, yes. Mm, close. Um, so firstly, something very important. A parameter has got nothing to do with functional procedure. Functions can have parameters or not, and procedures can have parameters or not. So a parameter works completely independently. They really got nothing to do with these two. But a parameter, I want to say, is sort of the opposite of these two. In the sense, a function tells you when the method is done, will it return something or not? And a procedure means it doesn't return anything. While a parameter is, does that method need anything to do its job? So it's sort of like an input part. This has to do, if I can just put it in inverted commas, this has to refer to the input part. However, our function and procedure refers to the output part. Like when it's done, what should it do? Should it return a value or not? Where our parameter refers to the input part. So does this method need information to do its job? So let's use my example again. If I asked one of you to go close the door, so or if the teacher asked one of you to go close the door, do you have to ask the teacher something before you can do that? And no. Yeah, do you agree? You'll just stand up, you'll just go close. You don't need to know anything. What if the teacher asked you, I want to, um, so let's say it's in the art room, and there's this shelf with all the different paints. And then the teacher says, I want you to paint a background on a canvas. Do you agree? Then you need to ask the teacher, what color do you want it? So now you'll need a parameter. So before you can do this job, you need some additional information. That is a parameter. A parameter is used for that. Like if, let's say you've got your maths marks, and then Mr. Zwanes tells Mr. Choto, increase the math marks. Do you agree? Mr. Choto needs to ask them by how much. So that means he'll need an input. He'll need a parameter. He needs to ask, like, what does he need to do? Or by how much should he increase it? And then he'll need parameters. But if it's just said, just go move a chair or just close the door or open door or whatever, then there'll be no parameter because you can already do that. Even, yeah, okay, let's just stick with that. Attributes, I did sort of explain. So this is, yeah, it's the values needed for the method to work. All right, but one other word just to explain attributes. I sort of explained, I just didn't write it down. What do you think attributes are? Yeah, characteristics of an object. So example would be if you take a student, his name or his name or his age or date of birth or grade or stuff like that. If it's a car, maybe how many wheels, what color, what year, and stuff like that. So all those things are attributes of an object. And then these actions we can do, the word we'll actually use for that is methods. Now, our methods can either be a functional procedure, meaning it will return a value or it won't return a value, and it can have parameters by does it need something or not. And that's sort of our key pieces of this object-oriented programming. We need to do those ones. Now, we do have some, I'm going to call it special methods. So that's like fixed methods that always does a specific job. Now, one of them is called a constructor. Do any of you that did OOP now, what does a constructor do? Mm, all right, say again. Okay, so yeah, it's a good assumption with the information you guys had. But what a constructor actually does, and again, so they can ask you this in your theory paper. But what your constructor will do, it actually creates an object. So that's the whole idea of it. Constructor means sort of, I think you all know constructor means creating. So what it actually does, it creates an object. And it does that by assigning uh, assigning values to the object's attributes. So the object will have attributes, and now when we create an object, it will assign values to those attributes. And that's what a constructor does. Right. Our next special method we've got an accessor. They also call it a getter. Oh, maybe before I do that one, let's go to words again. There's a word encapsulation. So encapsulation, any of you hear of that before? And then I think I saw it in Pavan's notes. All right. All right. Somebody listen a bit better who wants to take a chance there. So I sort of like the word isolation. It does fit in here a bit, sort of. Right. So encapsulation. So for me, so a capsule. If you think of a capsule, think of like the like medicine. When you've got that capsule, um, I don't know if any of you, if you like sometimes really sick or something, you've got that capsule that's like oval shaped, and then you have to drink that. But inside, if you broke it by chance, you'll see inside there's like lots of other small medicines all mixed up inside there, and that's sort of what this encapsulation also does. When creating an object or with OOP programming, we actually create capsules with this OOP programming. We want to create capsules that sort of hides information from other units. So you want to sometimes, in a big company, you'll have all the different kinds of programmers. And you'll have a group of people that's like, I want to say they're more academic people that's very good with maths and stuff. And they're creating their own methods. And some like, like when they create Windows and those, there's like hundreds of programmers that work together with it. And then there'll be that one guy that sort of, as an example, maybe needs to code the close button, and another person that needs to code the maximize and minimize buttons. So what they do is they create all the code, and then they sort of lock it away in like a capsule, so that the other programmers can't see what's in there. They can't look at the code, use the code or anything. The only thing they can do is what he allows them to do. So what encapsulation does, It's basically the hiding of information from other units or classes. So we want to hide some of the information from other units and classes because sometimes you don't want other people to sort of see what's happening in there, or other programmers or other programs for that fact. And that's where we use encapsulation. All right, good, Pavan. All right. Now, yes, I wonder. Yes, and we're going to go to that now. So, how do we, yes, that's exactly what I wanted now. So, we've got private, and what's the alternative from private? Yes. Um, so, if something is by private, who's got access to that? If it's in the private section, yes. So, it's only accessible by that unit. And public, the other units. So, and you'll see when we create our attributes, these attributes, they will mainly be created in the private section. So, if they don't say, then you create your characteristics in the private section. If they tell you they want these following attributes, but create them in the public section, then the only thing I don't want you to now think, hey, no, sysset must be in private, so I'm going to put it there even though they say public. No, if they say public, you put it in public. But if they don't state, 99% of the time, it must be in the private section. So, and that sort of creates this encapsulation for us. And that is one of the key things of OOP, object-oriented programming. Because the whole idea of OOP is to use objects. And objects are good because they've got attributes and methods. And these attributes are private, meaning they're encapsulated. So they all sort of go together. So you'll see your questions will, 99% of the time, will ask you to create the attributes, but create them privately. Generally, methods will be public, but it depends. Luckily, with you guys, the questions will guide you a lot as to what they should be, private or public, and then if it should be, yeah, whatever. All right, so now our first or another type of method. So we've got the constructor that creates objects. What do you think the accessor or the getter does? Yes. Yeah, so this is another type of special method. So the first one we get is a constructor. The next one is an accessor or getter. We're also going to do a mutator, which is also called a setter. And then we're also going to do the toString. That's our general basic special methods. So what the accessor does, do you agree with encapsulation? Our attributes are generally hidden. So we just said now attributes are private, and we said private is only accessible by that unit. And then when we started this lesson, I told you we're going to create it in one class, and then the other class must use that one. But now, if we do everything in our helper class, and we encapsulate it, we make it private, how would our main class then be able to access that? And that's where our accessor getters come in. Yeah. So we'll get to that now. So the helper class is the second class, the one without a GUI. Yes. Oh, all right. Yeah. So yeah, I forgot. So Delphi uses the word units, but you'll see underneath unit they actually talk about classes as well. So a class is the more generic one, especially you guys, if you're gonna go into any type of engineering or coding next year, you'll always hear the word classes and not units anymore. But it's the same thing. Yeah. So other programs. Yes. Well, yeah, it goes with the units. Every time you guys create another unit, you're actually also creating another class. Yes. Yes. Exactly. All right. So what our accessor does now is our accessor is a method that allows a method access method that allows, let's say, allows another let's say another process method access to an attribute. So that's what the accessor does. So our attributes are hidden or encapsulated, but now we can go create an accessor method that will actually allow us access to see what is there. So if you take that into consideration, what do you think the mutator or the setter does? Right, so our accessor gives us access. So let's just put it in another word. It's able to see. So now we can see what is inside there. So let's use our example of the car. If I create a car object, I would have a characteristic of, let's say, the odometer of the car is in there. And that is private. So we can't see that. But now, when we create our main class and somebody wants to buy that car, they'll ask, okay, but how many kilometers is on the odometer? Then we can have an accessor method that will allow us to see what is the value inside Odo so that we can display it for the user. So an accessor method basically allows us to see what is the value in the attribute, which was private. And then our mutator method, sort of mutator should give you the idea. So mutator is a method that allows another class's method to change the value of an attribute. So our mutator allows us to change that value. So if the odometer, if they drove around with it and now changed, then a mutator method will allow us to change that value. And then toString, I think you guys did toString, especially if you had now done like through 3 past papers. What do you think the toString does? Yes, so it takes all, or it takes, let's say it takes some of the attributes and combines them into one string. Yes, because now what we're doing, this will take some or all of the attributes and combines them into one string. So we need to make them all strings so that we can put them together. And then, so we do it, we combine them all into one string, and then with formatting. That's what it does. And it's mainly for display purposes. So generally this, again, remember now, our attributes are private, so they're hidden away. So, but now what this one does, it takes all those attributes, all those private ones that can't be seen on the outside. It puts them all together for us in one string. Then the main class, the GUI class, can just call this toString, and they basically get all the values already with formatting. So the tabs already in, currency is set, and then the main program can just display it. And that's the idea of this toString. Methods. And then the last one, methods, auxiliary methods or helper methods or user defined. The problem is different textbooks, different people call these things different things. So some people call them auxiliary methods, other call them helper methods, other call them user defined methods. But they are basically all other methods. So any other method you create that does something will basically fall into that category, where we can decide if we want to have it a function or a procedure, put it in public or private, have parameters or not, and then creating them. So these methods are basically all other methods. If they're not a toString or a mutator or access row constructor, then it's one of those ones. Then just for interest's sake, what's that word again? Inheritance. So inheritance is not part of your syllabus at all. So you don't need to worry about it or what it is. But what inheritance is, like with IB, they do that. And the difference there is, like you guys, you'll be taught how to do the helper method and to do your main class. And the main class will use the helper and it will display it and then we sort it. Now, what happens with IB, or let's say inheritance, they get another helper method. So if I use the example of, let's say like in a library, you could have a main class for the library where somebody wants to check out books. And so you'll have a helper method for the books. That will have the author and book name and pages and maybe type of book and stuff like that. But then with like author, usually the author will have a name and a surname, maybe where he's from, how old he is. So they will have another method, another helper method for the author with all the author's details. So how theirs work, their main library program will use the book class to get all the books, but the book class will actually use another method, the author one, to get the author's details. So it's like the one class is using another class, which is using another class. And that's called inheritance. So you're inheriting, you're using some of the methods of one class in the other class so that the other class can use it. So it's that step further. You guys just do OOP. You will always only have the one helper method, which is called by the GUI. So yours will always be very straightforward. I looked at last year's final paper as well, and it was really very straightforward. This question, at least, once you understand it, I want to say you can sort of book study it and then just understand it. I don't like teaching that way though, so that's why you'll see I spend a lot of time now explaining these words. Generally, people, if you feel a little bit lost now, it's not nice for me, but generally most people after this, they're not 100% there yet about how does all these things actually fit together. And that's where we actually need to now just see how can we apply these things. So, and that's what I want to start with now. And I think once we start doing this, it will make a little bit more sense to you. All right. So, generally, your question. Let's do a um, let's school student. Let's do a school student program. So, I'm not going to do any Delphi for now. I will. Um, what I'll do, I'll send you. I'll create a program or a question for you guys and post it. If you guys can do that before the next lesson and send it to me, that would be fantastic. Then I'll quickly just check if all of you are grasping the concepts. Also on Teams, not on Teams, on Google Classroom, I will create a folder for you with all past papers. And I'll put like every single paper I've got, I'll put in there. Then you can have a look at them with memos and everything. Um, all right, yeah, so let's go school student. Um, student. All right, so let's say example. All right, let's think. I want different data types. So if we think of a student, what will his attributes be? I want different data types. So attributes. So what do you think can be attributes for a school student? Yes, we can have his name. So his name is a string. Okay, we can have grade, which will be an integer. Um, so, okay, let's see. So we've already got an integer for grade, and we've already got the name on just different data types. Okay, but let's maybe. No, I don't want. I don't want more of the same thing. Let's see. Can we think of? Say again. Okay, we can do that. Yeah. So let's say real aggregate type real. All right, let's do one more character maybe. Maybe language. So character language, which will be of type jar. All right. So those things would be attributes for our one. So generally our attributes, what did we say? Will they be public or private? Yes. So we'll create them all in the private section. Then, except if they say something different, we'll have methods. And our methods will be created where? In the public section. Yes, public. We create it in the public section. So in this public section, when we create a method, you first, your first word, let's say, yeah, first word, let's do it this way. So your first word is one between three things. It is either constructor, or you say function, or you say procedure. So your first word, you choose between one of them when you're creating a method. So when will we use constructor? What do you think? Yes. So literally the question will tell you, they will actually say, this create this constructor that will assign these values or that will create the object or something like that. Then your first word will be constructor. Then what is our next word that we will choose between? What do you think? All right, our second word. Nearly. So our next word is actually the name of the object. Name of the method. Name of method. So that's the next word. Now, for a constructor's name is always create. So this is the name of a constructor. So, and that's just the way that Delphi is created. Some other, like Java that we use, they want to have the constructor will have the same name as the class. So if the class name is tschool, then the method name will be tschool for the constructor. But with Delphi, a constructor's name is create. But if you say constructor, you technically you can call it whatever you want to. You don't need to call it create. But we do, and they'll ask you to do that. You'll see it's even in bold in the question papers. They try not to confuse you at all. So our constructor will always be create. Our accessors and mutators, they are relatively easy in that an accessor our accessor, the name will be get and then basically the attribute name. So it's get and then so it will be get name or get name, get grade, get aggregate, get language. That's our accessors. They will always have the word get in front. That's why they also like to call it getter methods. So you'll see here with accessors, I said getter methods because I really love that. And then with our mutator is set. Does it mean when you don't have get that it can't be an accessor? No, you can it's a name. It's supposed to be that, but if you want to call it something else, you can. It's not like a must. It's just it's good programming convention that they like to keep it together. So our mutator are called set and then our attribute name. And then our toString is always called toString. I'm not even going to write that down. But then you'll see all the auxiliary methods. They're called whatever they want to. The question will tell you, call it increase grade or decrease aggregate or whatever. Then you just call it. And it's normally in bold. They try to keep it as straightforward as possible. So the third thing, I'm going to put word just in brackets. Because the third word we choose between is basically the brackets, which is our parameter. So the next thing you'll do, you'll either have brackets where, what do we use parameters for again? Who can remember? Right? Yeah, the method. Yes. So it's if our method needs any outside information to do its job. What we do have to remember, parameters are basically the stuff that you need, everything except the attributes. You know the attributes, even though they're private, they are created on top in that global area section. All of you familiar with global variables? Is there somebody that can't remember global variables? So just again, global variables are those variables that you create on top of your program, like on top of the unit, and they are accessible throughout the whole unit. So if this method needed to use the age, then you look in my attributes, do I have age? And you check, oh, I don't have age. So generally this method will then have an integer parameter that will get the age because it's not there. But let's say this method needed just a grade. Then it won't need any parameters because it's already got grade as a global variable inside this method. So our third word is the, yes, 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 that's it. So parameter is all additional information you need other than the attributes. Attributes is like available throughout the whole program. So it's anything else. If it needs some additional information, then you'll put it as a parameter. Right, and then so put it there. Parameters are basically sort of you create variables inside that bracket. And yeah, I will explain it a little bit later when we do that nicely. It's sort of like a teleporter because it will teleport something from our one unit to the other one. All right. Then when I see these brackets, it always refers to me to like Star Trek, you know, when they go stand on that beaming space. I don't know if any of you saw like any ads or whatever. But generally, if you saw something of Star Trek, you would have seen the people stand on a platform and then they get beam me out, Scotty, and they like disappear. So that's sort of these brackets. These are our, well, the receiving part. So they're beaming into our ship with us. We're receiving those values from the other place, from the other mothership. All right. And then our fourth part. So the fourth. I don't know how to spell fourth. Oh, did I spell that correctly? Yes. All right. So the fourth word technically um, only appears. Uh, so this is only for functions. So only functions will have this fourth piece. And what did we say again? What does functions do? What's the difference between a function and a procedure again? Yes. So a function returns a value. So this fourth word is basically a colon with a data type for the return value. So you'll see if this method needs to return a string, then you'll have colon string. If it needs to return an integer, it will be colon integer. The trick with this is, with functions, they can only return one value. You cannot return more than one value. So I think some of you might want to ask me now, but sir, can't we return an array? So yes, you can do that. So we can return, so maybe using value is the wrong word, we can return one structure, or I want to say one variable inside quotes. So it can be one variable or one array you can return to use it. Arrays, however, in this section is not part of your syllabus, so you don't need to worry about that. It is nice to know for your pet. When we've got the pet topic and we're going to work on our pet, if you get to that stage where, because you need to use OOP as well, you get marks for OOP. I'll just see on the second when I get your pet rubric where the marks lies and how they changed it. But generally, you needed to use OOP and you needed to use arrays. Not necessarily together, but sometimes your task might need you to return an array, and then just it's good to know that you can do that. And if you want to do that, you'll just tell me and I'll guide you through the process on how to do that. Yeah, no problem. So remember I said with this one, my example for functions was like, I wanted you to go count how many chairs was next door. So then you came back and you said 40. So that would be just returning an integer value. What if I asked you, please go to all 5 classes next to me and tell me how many chairs are there in each of those classes? Do you agree? Then you wanted to tell me the first class had 40, the next class had 30, the next class had 20, the next class had 10, and then another 10. So now you didn't want to just return one value to me, you wanted to send an array of answers to me. Or if I asked you, like, go next door and give me a name list of all the students in that class. So now you don't want to just give me one string, one name, you want to give me a whole list. So that would be an array of names that you actually want to send back to me. Yes, yes. So it's an array of type string. Yes. So then that we can also put here. Um, but as I said, For your exam purposes, you don't need to worry about it. Or for class tests and stuff, you don't need to work with arrays in the returning part. So that's not part of your syllabus at least. So you don't need to worry about that. And then also just for your PAT so that we're doing OOP here. For your exams and for class tests, you only need to work with one object. So you'll see at any stage, using values, you'll create one object and work with that. So my example of the student, you'll only create, let's say one student, they'll only say, enter Pavan's details and then call these methods with it. So you're only working with one. You can create an array of objects. So if you wanted like all this information for all 40 students in the class, remember like we created an array of type string to keep all the names, and an array of type integer to keep all the quantities, and an array of type real for all the prices. You can go and create an array of type student so that you can keep 40 students in an array. So that again is something for your pet. If when you're thinking about your pet and you're thinking, hey, that would be nice, I really actually want to have an array of objects, then again, talk with me and I can guide you through it. It is really actually easy. If you understand OOP and if you understand arrays, it's a very easy next step. But it's not part of your syllabus again. So you don't need to worry about it for test purposes. You won't be tested on it or examination purposes. But it's there. Yeah. So just keep in mind, you can do it if you feel you want to use that in your pet. Then talk with me and I'll help you through it. While I'm talking with Pat as well, there's always a section where you need to do stuff out of the syllabus. So also think about that. Then I can guide you with ways either maybe to use graphs or like video clips and stuff and sound clips to put that into your pets. But we'll do that once you start thinking about it. I want to say it is relatively easy. There were some of my previous students that had like text to speech where it would actually read for you what was written. So, like when you displayed something, it didn't just display it, it was actually, sort of like one of those accessibility options where somebody with a reading disability, where it would actually read out the options to you. So that was like really cool. So it's really, I want to say there's a lot of things you can do. It's sort of your imagination that could block you and time then. So we'll just see because it will take time to do those things. But yeah, so be creative, and if you've got a plan, then talk to me and I can help you realize it. All right, but that's creating our methods. So how this works, you remember with OOP or with any of our programs or with this part, you actually create it on top in that first section there, either between public or private or by the var area, just there above our implementation. Then we're going to press Control-Shift-C and it actually creates the methods for you at the bottom. And then we just need to put in the code. So that part I can't easily do here now because, yeah, it's more for inside Delphi. But you'll see the code on the inside is actually very straightforward. Like our constructor, literally like what most people said, what our constructor does, we're actually assigning values. So you literally have on the left-hand side all of your attributes. That's a key thing maybe to remember. Your attributes will always be on your left, and then your parameters will always be on your right. Some students swap that around a bit, but that's, I want to say, key. But we'll do that, and we're going to do that next time. So I see our time's nearly up. But yeah, maybe before I go off this point. So the rest inside the methods themselves are normal code like you did last year. It's really nothing special about it. You can use if there if you want to, use values to calculate averages, when we do our toString, we need all the conversions. You'll do your plus 13 for your new lines and plus 9 hash 9s for our tabs. Um, inside these methods are normal everyday code that we've always used. So what I'll do, I'm going to give you a program just to test on these things. And you'll see the question will guide you a lot. We're just going to do this section. Then next week, what I'll help you with is the main program itself, on how that looks and what we do there. Yeah. Any questions from here that anybody got? Yes. Okay, let's do an example. I think that would just be easier. So how the example would look. So as you said, this will be in our public area. So inside the public section, first word will be one of them. Let's do a constructor. Let's say examples. So our first word would be like constructor. And then our constructor's name will always be create. And now with a constructor, we're creating an object. So when we create um, this object for the first time, you agree, we don't actually know what the values are. So your constructor is like one of them that you basically always have parameters. You do have a constructor that's empty parameters. That will just be like that. So you do get a constructor that's literally only that piece. And they call this a default constructor. So default constructor is that one. Let's say you know you're going to get a car. Let's do a car lot again. Let's say you know you're going to get a car in, but you don't know anything about it, but you just want to create the object in the meantime. Then you create like a default constructor. Generally in a default constructor, your attributes get just like either blank values or zero values, to just understand. Then your next one would be constructor. You can create another one. Let's call it create. And then in our brackets, now we can actually give it some values. So our example we had, we've got name, grade, aggregate, and language. So what we can do here is we can have, let's say, just name, type string. So we're going to get a name. We're going to get, what was the next one? Was age? Was it age? Grade. It was grade. Grade of type integer. And then our next one was, what was the next one? Aggregate. So it's aggregate. That was of type real. And the last one was character something, language. Type jar. All right, so it would literally look like that. You'll see I changed the names. The other ones had the S name and I grade and R aggregate and C lang. But these things, remember, these things are parameters. So they are not the same. Because what we'll do now on the inside, so you go the control plus shift plus C, and then it creates the section for you that looks like this. Will be on top. But you remember, just more down. Let's say, let's put this in a new stage. So what you'll do then on the inside of this one, then you'll have your begin and end here. Begin and end. On the inside here, remember I said it's always your attribute equals the parameter. So how this will work now is our attribute, which was S name, gets the value of our parameter, which is just name. and our attribute iGrade will get the value of the parameter, which is just called grade. And our real aggregate gets the value of the parameter, and our ceiling. Yes, talk to me. Sort of. So remember, they're not individually made public, but this method is public. The constant, well, all the methods generally. So all of them. So if I call any of these other methods, any of the methods I call, whatever they're doing, I can use from another class. But I cannot access the attributes individually. Like that is name is hidden. But name isn't, but name is only available with inside the constructor. So actually I have to call a constructor to create the method, then I can use name, but just for this method. Yeah. So let me explain it this way. So how it works, when you play this program, your main program will be running. And remember, that's your GUI one. So in that one, that's your access to the users. Um, Generally in a IT company, let's go that through so I understand the reasoning behind this. If you want to go work for a software company, you'll have different types of programmers there. You'll have the ones that's very arty. They just love to make stuff look beautiful, and if you can sort of think for yourself with me, people like that, they don't care so much about the program itself. They just want it to be easily usable and look nice. So the buttons must look nice, must be placed in the right place. When users use it, it should be easily accessible and a lot of help features. And so the people creating the GUI are those programmers that don't actually care about the resources and stuff like that. They just want it to look nice and work easily. But then you also have the other programmers that really just wants this program to work as efficiently as possible. So they don't care so much how it looks, is it easy and stuff like that. So companies employ both of these ones. So they'll get the one person to create the GUI, and they'll get the other person to work with the helper method. So, and then they'll say, all right, I need a program that can store the data for students. I want to store the name, grade, aggregate, and the language for each of the students. Then the art guy will go and he'll design a nice screen with combo boxes and radio buttons and images and all that stuff. And he'll ask him, what is your name? What is the grade? What is the aggregate? What is the language? He'll get all the information for us. Now, what the other guy needs is that helper guy. He needs to know, okay, I'm going to get these values from the other program, but then I just need to work with it. So the GUI method will get the values, put them in his own variables. Let's say the variable is called just n. Let's say for name, he just called it n only. So the GUI gets a value for name, puts it into n. Now, that's what I'm going to show you next time. So next time, I'll show you, he's going to take that value of n and put it as a, I forgot the name. I've got aggregate in my name, argument. So, but I'll show you where the argument. So he's going to put it inside brackets as an argument, and what it does, that variable's value will get sent over to our program, and then we are going to put it inside this variable. So this is sort of like the catching area inside this program. So the first value we receive is going to go into this variable. The next value we receive goes into this variable. The next value we receive goes into this value. And the next one we get will go into this one. So we'll get 4 values, and we're going to put them into these 4 spaces. But these 4 values or variables, They are local variables. So because they're inside the parameter section, they only exist within this button. As soon as we see the end, parameter name, grade, name, grade, aggregate, and L, these four don't exist. After this end, they all disappear because they were created here inside the parameter section. So they're temporary variables. But now they've got name, a name we want to keep actually. So we get the name and we just transfer that to our global variable sname. So that then goes into this global one we created. Okay, which I didn't do now. But yeah, so the global variable we created goes into him. So that we can use it in all other methods. The same with grade. Our temporary variable, which is our parameter, we take the value and we just put it into our global variable, the attribute. Same there, same there. So that now these global variables we can use for whatever reason. Did I sort of explain? Do you get it? All right. I maybe want to add to this. It seems stupid this because some of you will say, why do I get it into one just to move it to another one? It's sort of like, why would do that? The thing is, remember, we're doing small programs and we're just trying to teach you guys concepts. But you'll even see sometimes, let's say like this language one. Let's say we want it as a character, but what we're getting from the user might be a whole string. So what we do in here, instead of just assigning, this could be either if function, or we can even do, maybe use that extracting a particular character out. You remember, how do we do that again from a string? How do I get the first character out of a string? What method can we use? So again, if I've got a string and I only want the first character, yes. So winner's contract, we can use the block brackets, but there's a method as well when we just want a part of a string. Yes, we can use copy as well. Yes. So either the square brackets or copy. So it could have been maybe the L square brackets one. Or we could have used the copy to get the first one and put that into there. Sometimes with aggregate, maybe instead of just receiving the aggregate, maybe they're sending us 5 integers or 5 reals, and we needed to calculate it here ourselves. So that can also happen. So it doesn't necessarily, with you guys, it will be very straightforward. Generally, it's just receive and assign. But I mean, if they wanted to, there could be calculations in here. It doesn't need to be just straightforward. So it could be like I'm just showing you here now, where we can go and actually use a method to actually access it. And use, with this one, maybe add 5 numbers, divide by 5, and then store that value in there. That could also be fine. So these ones, our parameters we're receiving, temporary variables that we're just receiving into our constructor, and then we have to decide, do we want to keep them as is and give them to our attributes, or do we want to change something of them first and then assign them? Maybe make the name capital letters and then only assign, or whatever. Use our uppercases and all that stuff. So we can work with it. Generally with you guys, it will be straightforward, but yeah, keep it in mind. We can do changes here and then assign. So that's the idea behind this constructor. We'll receive temporary variables and then we assign it to our global variables to work throughout the program. All right. And then so I've done constructor now. Yes. Yes, that's our attributes. Yes. Perfect. And then our next one, let's look at like a accessor. Let's look at how the accessor would look. So an accessor, which word do you think it will use? So remember the accessor, what it does. What did we say the accessor does? Yeah, so remember, so we're in the helper class at this stage. So what the helper actually does, remember, it gives access to an attribute to the main class. So basically what it does, it actually sends our attributes value to the main class. That's what it does. Let's just see what I say. So let's put it in here. So it sends the attribute to the other class. So this is what it does. So it sends our attributes value to the other class. So if you keep that in mind, what will be our first word for an accessor function? Because we're sending it. Do you agree? So we need to send something out. So that is a function. And then the next part, remember, is the name for it. So what did we say when we're creating accessors? How does the name look? So accessor starts with get. So let's call it get name. Let's do it for the name one. What is our third word? Our third word is the parameters. Like, Pavan, if I needed to ask you, hey, what's your name? Do you need to ask somebody for something before you can answer me? You'll just answer. So you don't need any additional information. Do you agree? So we don't need parameters. So then our fourth part is, and it's only for functions, and we are busy with the function, and this is the data type for the return value. So if we're going to return a name, what do you think the data type will be? String, yeah. So we're returning a string. And that's literally how this one will look. If I do a mutator, so that remember the mutator, he just does something. So what will his first word be, do you think? Yes. And then with our mutator, it's called set. So let's set grade. Let's say we want to change the guy's grade. So we set grade. So our third part, remember, is our parameters. If I asked, if I asked you to change somebody's grade, do you need to ask me another question? Let's say, no, one day I'm asking you, please change Pavan's grade. Do you need to know any information from me? Yes, do you agree? You need to know what you want to change it to. So generally with a mutator, you need parameters, and we need the new grade. So let's call it new grade, which will be an integer. And then because it's a procedure, will we have a fourth part? And the answer is no, because remember our fourth part is only for functions. It's the return type, and there's no return. So that's literally how they would look. Yes, talk to me. We just, out of my head, I just made an example. No, so you write it yourself, but the question will guide you. They'll tell you create a accessor method for name, and then you know, okay, I have to call it because it's an accessor method for name. I'm going to call it get name. Generally, they actually tell you create an accessor method for name and call it get name. They'll actually give you the name most of the time. They'll tell you what to call it, and then they love to put it even in bold so that you don't get confused. But yeah, they'll tell you. So they'll tell you create an accessor method maybe for age, and then you'll call it get age. So, or a mutator for name, then you call it set name. Okay. For me, the main thing to understand now is when to use function and when to use procedure. And then when do we have this part? So when we've got a function, we have to say what data type it is. And when we've got a procedure, we won't have that. And yeah, just take note, even though we've got these parameters here now, parameters can be anywhere. They can be there as well. It's just for this particular instance, we didn't need it there. Um, yeah, all right. I think that's how far I want to go tonight because you guys have got school also till tomorrow. Any more questions just about tonight's work that you maybe want a little bit clarity on? I know I did a lot of theory, and this work that I've done now, I will post for you also on Teams so that you can have this. And then, yeah, if you can then, as I said, I will send you a work where we can just do the class for next time, and then I'll go through this nicely with you, and then we're going to look at the main program. And then, so after next time's lesson, we should be fine with OOP. Then I'll just give us some practice activities. But do all of you, any questions around what I've done? Or you think you sort of got it? All right. Thank you very much, everyone.